Welcome students. Today we will discuss about how to solve the Rastrigin problem using simulated annealing algorithm. The objective function for Rastrigin is given as sigma over I turning from 1 to d xi square minus 10 cos 2 pi x plus 10. Here you need to understand x, it is a real value. So first we will modify it. Let us find out integer solutions also, and the dimension is given as 5 and the number of iterations as 1000. Initial temperature is 10. Let us implement. So we already know that simulated annealing algorithm is provided in the R package in the form of optim function. So let us see the first argument. S is the initial solution, and second one is the objective function, and then third one is the change function, fourth one is the what type of algorithm, here simulated annealing, so we have to pass SANN, and finally the control list parameters. So actually the first step is not necessary. We are implementing from the previous videos. So first write down the Rastrigin function. So you need to understand that Rastrigin function is given like this. So by default we already told you optim function performs only minimization. So for finding the maximum value for this Rastrigin function, we have to modify the objective function like the inversion of the objective function. So if you find the if you give this objective function, you will get the maximum value. Okay, so just we have modified the function in the form of inversion, and then we performed the simulated annealing technique. So the dimension is given as d5, and we are starting with from 0 0 0 from origin, and then we define the control list parameters. The first argument is maximum number of iterations. In the question they have given 1000. So what we will do means we will go 10,000, and the initial temperature is set as 10, and then for each temperature you can put maximum number of evaluations, okay, as a 10, and then for reporting the results you pass these additional arguments. So all these should be defined in the form of a list data structure, and then the step change function. So we already told you the old value plus some change. So this function accepts the old value PAR, and what we will do means we add this step value. It is sampled from the normal distribution function. It is having its mean 0 and standard deviation 1. So first we will try with integer solutions. So we rounded off, we rounded, and then we added to the old solution. Actually this step is same as this one, and then actually this step is not necessary. We just let us suppose we are not clipping, so we want to find out over whole space. Okay, so in such a case you can remove. Actually this statement is for clipping minimum and maximum values. So in our question it is not necessary. Why? Because there is no maximum and minimum range for a variable. Okay, so it is not given in the question. So let us comment it out and just return the new value. Okay, so we return the new value, and then we call this simulated annealing function. S is given, defined, Rastrigin function has been passed, so that means this function. Okay, and then the change function is already given here, and then the type, what type of optimization technique, and then control list parameters. So it is not necessary. So by doing this, let us say we select it, let us run. So we will run this algorithm for 10,000 iterations. So we got integer, actually we have taken the integer. So at this solution we got the maximum value. Okay, so let us suppose we want to find out, this is the maximum value. Okay, this is a maximization. Suppose we want to find out the minimum value for Rastrigin function. You remove this inverted function and then let us save it, again try to run it. Is it running? Okay, once again I will run it. Yes, so we got 0. So this is the minimum value we got. Say for example we want only the real values. Okay, let us in this step we have to comment it out. Let us run. So in this case also the same thing we got. Let us modify the function. So like this you have to you try different values, you change the parameters. Okay, now you get some real values, you can see the difference. Okay, so let us find the integer solution, let us remove it and you save it. So okay, so at this we will get maximum value. This is a maximization problem because we changed the inverted function, we changed the objective function by taking the inverse of it. So we got this value. Okay, thank you students. Let us analyze it.